In this video, we are going to talk about how to find the midpoint and distance between 2 points. We won't talk about slope though, so that's a typo there. So let's get right into an example. So for the points, I'm labeling this first point P1, and the coordinates are -3, 2. The second point P2 is 1, 7. I first want to find the distance between P1 and P2. So let's plot these points. So the point P1, x is -3 and y is 2. That would be here. So P1 occurs when x is -3 and y is 2. And then P2, the x value is 1 and the y value is 7. So that would be somewhere up here. So P2 is at 1, 7. So the graph extends higher. So imagine I have my y value 6 and the y value 7 there. Okay, so we are interested in finding the distance between these 2 points. All right. So, thinking about what we talked about in the last video with the Pythagorean theorem, one way I could do this is by adding some lines to make a right triangle. So I could draw a horizontal line like this across, and then a vertical line straight up until I get to P2, and then I make a right triangle. And from here, now I can figure out the lengths of this base and that height. So, I can even count it to get from here to here. I go 1, 2, 3, 4. So that's a length of 4. So it's a horizontal length of 4. And then to go vertically from here to here, well, to go from a y value of 2 up to a y value of 7, that's going to be a difference of 5. So vertically it's 5. So if I want to get this distance, so maybe I'll call the distance capital D. Well, one way is with Pythagorean theorem. I could say that 4 squared plus 5 squared equals D squared. And then, 4 squared is 16 plus 5 squared is 25 equals D squared. And then 16 plus 25, that just becomes 41. And then if I square root both sides, I'd get D equals square root of 41. And I don't need a plus or minus because a distance cannot be negative. Okay, so that's one way I could get to my answer. I also want to talk about a formula we can set up for the distance between 2 points. That comes out of the Pythagorean theorem. So what's the idea for this? So I'm going to refer to a picture here on the side, and I'm going to label my points generally as x1, y1. And then the second one, x2, y2. And then what I'm going to do is I'm going to indicate what this distance is. So that horizontal distance is based on what was the bigger x value minus the smaller x value. So that would give me x2 minus x1. And then to get that vertical length, well, I subtract the y value. So bigger y value minus a smaller one. So that would give me y2 minus y1. So now if I do my Pythagorean theorem here, and again, if I call this hypotenuse D for distance, what I get is, well, this leg squared. So I get x2 minus x1, that whole quantity getting squared, plus the other leg, which is y2 minus y1, that one getting squared. Well, that should be equal to D squared. That should equal the hypotenuse squared. And then if I want to get D, I square root both sides. So let me write D first. And I'll get a big old square root on my x2 minus x1 getting squared plus our y2 minus y1 getting squared. And it might be tempting to say, well, can I just square root this thing and then square root that thing so I can cancel these squares? But no, I cannot do that. Because remember, if I have a root, I'm not allowed to distribute it when the terms inside are being added or subtracted. So I would just leave it like this. So what we've got here is what's called the distance formula between 2 points. So let's also apply this to the example that we just worked out here. So what if I did the distance formula? Well, it would give me D for distance equals big old square root. And then what I do first is I subtract the x values and then I square that result. So subtracting my x values, let's see, one of the x values is 1. 1 minus, and the other one's -3. Well, I'll get a double negative. Squared, and then plus. Now I subtract the y values, and then I square that. So plus 7 minus 2, that quantity is going to get squared. So the double negative becomes a plus. And then what I get, whoops, let me write that second one better. Well, this is going to be 4 squared, which is 16. This is 5 squared, which is 25. Ooh, and now that's working out to the same thing that I had here. I'm getting that d, this distance, equals just the square root of 41. Okay, so I'm getting the same answer, whether I use the distance formula or whether I bypass it and just go straight to the Pythagorean theorem. But that's where the distance formula comes from. It comes from the Pythagorean theorem. Okay, so now let's shift gears. Let's do another example. What if I want to find the midpoint of these 2 points? So the point that's exactly halfway between these two. So the midpoint might be, I don't know, somewhere here, halfway between these two. Well, there's a formula for that. To get the midpoint, what we do is you'll average the x coordinates. So to average them, you take the first x coordinate, add it to the second one, and then you divide it by, well, how many terms did you add together? Well, I added 2 together, so divide it by 2. And now I average the y values. So I'll get y1 plus y2 divided by 2. Okay, and if we plug into this, I actually want to have you do a quick pause and try plugging into this. So give it a pause for 30 quick seconds and try plugging into this. So pause it in 3, 2, 1, pause it and try that. Okay, so hopefully you did. Let's bring it back. Let's talk about it. So if I plug in -3 for x1 and 1 for x2, what we'd get is -3 plus 1 getting divided by 2 for the x coordinate. And then plug in the 2 and the 7 for the y values, and I'll get 2 plus 7. That's going to get divided by 2. So this first fraction's -2 over 2, which is -1. And then the y value becomes 9.5, so 9 over 2, which, if I wanted to write that as a decimal, is about 4.5. So visually, if I plot my midpoint, I know now that the x-coordinate should be -1. And it looks like in the graph, if I draw that a little better, yeah, the y value seems like it might be 4.5. You know, not perfect in terms of my picture, but, you know, seems reasonable. And there we have it.